Welcome to video 6 on applications of vectors. Let's look at the properties of the dot product. If you have u dotted with v, that's equal to v dotted with u. If you have a times u dotted with v, that's equal to a times v dotted with u, which is equal to u dotted with a times v. If you have u plus v dotted with w, that's equal to u dotted with w plus v dotted with w. And if you have the magnitude of u squared, that's equal to u dot u. The dot product theorem states that if theta is the angle between two non-zero vectors u and v, then u dotted with v equals the magnitude of u times the magnitude of v times cosine of theta. Note that theta must be between 0 and pi. If theta equals pi over 2, the vector u and v are said to be perpendicular or orthogonal. This happens if and only if the dot product equals 0. We will be asked about being perpendicular or orthogonal in the future, and so we'll definitely want to keep that one in mind. The angle between two vectors can be found if theta is the angle between the two non-zero vectors u and v. Then if we solve for cosine of theta from the previous formula, we can get u dot v over the magnitude of u times the magnitude of v equals cosine of theta. Let's find the angle in degrees to one decimal place between vectors u with components 4, 1, and v with components 2, 3. Well, we know that u dotted with v equals the magnitude of u times the magnitude of v times cosine of theta. If we want to find the angle in degrees to one decimal place between the vectors, then we just take the two vectors and substitute them in. We have 4, 1 as the first component vector, dotted with 2, 3. And I know this is equal to the magnitude of u, so let's find the magnitude of u. Recall that that's the square root of 4 squared plus 1 squared, which is equal to 16 plus 1 under the square root. So that's the magnitude, square root of 17. If I want to find the magnitude of v, I'll do the same thing. I get the square root of 2 squared plus 3 squared. That will give me the square root of 4 plus 9, which is equal to the square root of 13. That means that I will have these two vectors dotted, which is equal to the square root of 17 times the square root of 13 cosine of theta. Now remember, I'm trying to find the degrees between them, which means I need to divide both sides by the square root of 17 times the square root of 13. If I want to find cosine of theta, I just need to simplify this numerator. I'll have 4 times 2 plus 1 times 3, all divided by the square root of 17 times the square root of 13. That's equal to cosine theta, but I actually need the angle. So simplifying further, I'll have cosine of theta is equal to 8 plus 3, so that will be 11 over the square root of 17 times the square root of 13. And then I will find theta by taking the cosine inverse of both sides. Don't forget to put your calculator in degree mode because this is asking for in degrees. Since we're rounding to 1 decimal place, this is going to be 42.3. degrees. Let's take a look at the next example. We need to determine which of the following pairs of vectors are orthogonal. Recall, a vector is orthogonal if they're at right angles to each other and the dot product equals 0. If we take u and dot it with v, that will give me the vectors 3, -2 dotted with 4, 6, which will be equal to 3 times 4 plus -2 times 6. If I multiply 3 times 4, I get 12. And if I multiply -2 times 6, I get -12. This is equal to 0. So u dotted with v vectors equals 0. Therefore, these vectors are orthogonal. Now let's try the next one. If we dot the vector u with the vector v, we will have the components 2, -1 dotted with the components 1, -2. If I multiply them respectively, I will have 2 times 1 plus -1 times -2. This will give me 2 plus 2, which equals 4. These vectors are not orthogonal.